Welcome, ladies and gentlemen. Let's go ahead and factor out the greatest common factor. So we first want to scan the terms in number one and see what's the greatest common factor present in each of the original terms. And it looks to me like they all share a 2. They all have x's and they all have y's. But the greatest common factor, right, includes the largest number of x's and y's that we could factor out from each term. So let's go ahead and factor out a 2 and an x. And it looks like everybody has a y squared to give. And so we'll go ahead and factor out the greatest common factor in a reverse distributive problem, and then consider what remains. And so 2xy squared times what equals 4xy squared? Well, that's just 2. And so what remains of that first term inside my parentheses then is just 2 after factoring out the greatest common factor, 2xy squared. Minus, it looks like we already have the 2, so we just need one more x for that middle term. And then lastly, 2xy squared times what equals negative 2x cubed y cubed? Well, it looks like we need 2 x's now and 1 y to get all the way to our 2x cubed y cubed. Raise your hand if you had number 1 correct. So who had number 1 correct? Good job with the exponents, you guys. That's great. Stop. Think. GCF. Is there a greatest common factor hiding inside each of those terms? You bet your boots. And if my leading coefficient is negative, I like to factor out a negative as part of my GCF, just so that my first term in parentheses doesn't include a negative sign, so that the reader wouldn't be confused and think that it's subtraction, because it's certainly not subtraction. It's multiplication for a reverse distributive property problem. So here we go. I'm going to factor out purposely a negative 3a cubed b cubed. When I do that, what remains inside the parentheses is a, b, in order to get the original first term, negative 3a to the 4th, b to the 4th, plus, nope, minus. We need a minus, because a negative times a negative then would be a positive. And we need just 2, right? Because we already have the 3 a's and the 3 b's in my greatest common factor. If you factored out just the 3a cubed b cubed, that's fine. You'd have a negative ab and then plus 2, and that's still correct. It's just I don't want someone to think that this is subtraction here, right, when it's multiplication. Awesome. Raise your hand if you had the equivalent to number 2. So you had the equivalent to number 2? Great work, you guys. Let's go ahead and make some boxes here so we can save these. All right. Number 3 is my favorite kind. Factoring a trinomial into a product of 2 binomials, every problem is like a puzzle. We're trying to figure out the pieces from whence it came. That is, the 2 binomials, such that when multiplied together and combining like terms, produces that original x squared minus 4x minus 32. These are my favorites. So let's go ahead and rewrite this then as a product of 2 binomials. We'll fill in my variable x and x. I know that my first product, x times x, will give me x squared. And now we'll go ahead and consider the integer pair factors of my last. My last is negative 32, and I know that that's a highly composite number. I have lots of choices, and so 1 plus or minus 1 and 32 is one choice, but also, right, 2 and 16, but that's not all. 3 and, nope, 3 doesn't go, 4 does though. 4 times what? You can call out? 8. 4 times 8, thank you. 5, no. 6, nope. 7, and then we're back to 8, and so we've got all. So we've got 3 different choices, right? We've got 3 different choices. Which one is correct? Well, that depends on the sign of my last term. It appears as though the sign of my last term is negative. Therefore, will my entries in my binomial that go on the last space, will they be same sign or different sign in order to multiply together to give me that negative 32? The only way to multiply two pairs, right, 2 numbers together and produce a negative result is if they're opposite signs. So one's going to be positive and one's going to be negative. We no longer have 3 choices for my integer pair factors. We only have 1 choice. Given that my entries are going to be 1 positive and 1 negative, now I can see which integer pairing is going to work so that they sum to give me this middle term of negative 4x. Go ahead and raise your hand when you found the winning pair. And which pair must I use then to sum to negative 4x? So what's that going to have to be? Carson, you?
4 and 8.
4 and 8 in that order? Let's see.
8.
If I did an outer product, I'd get x times negative 8 is negative 8x. When combined with my inner product of plus 4x, that would sum to give me the negative 4x in the middle term in my original trinomial. Good job. Thank you, Carson. So that's absolutely right. So we can check every single answer, right? By doing a FOIL problem, again, we can multiply first the outside product, negative 8x, the inside product, plus 4x, and the last product, negative 32. Does that equal my original? Absolutely, so we're correct. Raise your hand if you have x plus 4 times x minus 8. You could also have x minus 8 times x plus 4, but the negative has to go with the 8 and the positive has to go with the 4. Nice job, you guys. What questions do you have about number 3? We'll be doing lots more of those kind today. And then special patterns, right? Special patterns, really, we're factoring just like we were at number 3. It's just that we oftentimes can be clued in on the presence of a special pattern if we see those perfect square numbers. And so as I look at this, in this set of problems, I'm seeing that 25, this 16x squared, this 9y squared. 25, 16, and 9 are all what kind of numbers? Well, they're all perfect squares, and so that's an indication that we might be having a special pattern here. Let's go ahead and see. So we'll make our pairs of parentheses. What times itself equals 1x squared? Well, x and x. What times itself equals 25? Well, 5 and 5. Given that my last term is positive, are my entries in my binomials going to be same sign or different sign? They have to be same sign. To multiply two integers together and get a positive result, they have to be same sign. Given that they're same sign, if my middle term is negative, they must both be negative. And so we get x minus 5 times x minus 5. Raise your hand if you had that. So who had x minus 5 times x minus 5? Good job. On the worksheet key, you might see this rewritten as x minus 5 quantity squared. Either one is correct, right? Isn't that x minus 5 quantity squared? That means time itself. Notice how this does not equal x squared plus 25. This is a trinomial. Whenever you take a binomial and square it, the result is always, always, always a trinomial. There will be a middle term when my outer product and inner product combine. So either one of these is correct, right? Either one of these is correct, and you'll get full credit for putting either one on your quiz. All right, stop. Think. GCF? No, there's no common factor hiding inside each of those. Let's go ahead and make our parentheses pair then. What times itself equals 16x squared? Oh, 4x and 4x. What times itself equals 9y squared? Well, 3y and 3y. In order to have a negative last term for my last term in the original, I must have same signs or different. Well, they must be different, and that's great news because now my outer product, when multiplied out, negative 12xy, when combined with my inner product, positive 12xy, will sum to 0 and there won't be a middle term. So our original binomial, right, we could call that a difference of perfect squares, and the result then is same entries but opposite operation. Awesome. What questions do you guys have about our Bellwork answers today? Then we've got a pretty sweet rectangles here. See these elongated rectangle answers, so there's a quick way to check our answers. Again, if you didn't factor out the negative in number 2, that's okay, that's still correct. All right, let's go ahead and take out our worksheet number 3 then, please. Make sure that your name is on top of your worksheet number 3. And this is a fairly lengthy assignment. It's because we've got lots of different factoring strategies that we need to practice. In order to be a good factorer, we have to practice, right, the skill, and we become better at factoring the more that we do it. I'm going to go ahead and pause the recording as we check our answers, but I did post these on the back whiteboard, and you're welcome to check these again during work time. Our last two methods of factoring then are factoring a trinomial with a leading coefficient other than 1, and so like number 3 in your Bellwork, but instead of just being a 1x squared minus 4x plus u minus 32, it'll be something like 3x squared minus 17x plus 32, something like that. And then also factoring by grouping. Factoring by grouping problems are easy to recognize because they're the kind that have 4 terms in my polynomial, so we'll be on the lookout for that. All right, so we will have several strategies at hand. First, we always want to see if we can factor out the greatest common factor. So regardless of what type we're going to do on your quiz, your first step should always be stop, think, GCF. Is there a greatest common factor hiding inside each of the terms that you could factor out in a reverse distributed property problem and result with smaller numbers, right? So even if you have to continue factoring, you'll be doing so with smaller numbers. Next, you want to see if there's a special pattern involved. And so oftentimes, if you have a binomial there, like a squared minus b squared, then it could be a special pattern, a difference of perfect squares. If the expression remaining has 3 terms, then we could try to factor it into a product of 2 binomials. We're going to continue to work on that trinomial factoring today, where the leading coefficient is not equal to 1. So when we have a leading coefficient not equal to 1, and that adds another layer in our factoring strategy. So when factoring a polynomial when my leading coefficient isn't just 1, notice how our same interplay between the signs of that constant term and the sign of my middle term will be used to determine my ultimate choice. However, we now have a ax squared in front, not just a 1x squared, and that's going to change my strategy by adding an additional layer. I now need to consider not only the factors of the last in my original polynomial, I also must consider the factors of the first. To see why that's important, let's go ahead and multiply these 2 binomials together just as if it were a Bellwork question from last class. So remember, we could do 2x times 3x, and we could call that my first, right? That's my first product. 2x times 3x is 6x squared, and I can consider that as my first product because it's the product of the first terms in each binomial entry in the original. Then I could do 2x times negative 2, that's minus 4x. I could call that my outside product so that we have a common vocabulary. That could be the O in FOIL. That stands for the outside product because they're the outermost terms in each of my original binomials. Then the I would be the inner product, the inside product, because those are the innermost factors in my original binomials. Negative 5 times positive 3x would be negative 15x. And then lastly, in blue, negative 5 times negative 2, that's the last product. That's the L in FOIL because they're the product of the last terms in each binomial. What's negative 5 times negative 2? Well, that's positive 10. And this way we can see our F, O, I, L, first, outer, inner, last. Now, is that my final answer? No. But we can see, right? We can see now why it matters, the placement of that 2x and the 3x. That affects my outer and my inner product. And that's going to ultimately determine that middle term in my final answer. That's going to be important when we go backwards in factor. So what would a middle term be here? It would be negative 19x, right? So my final answer would be 6x squared minus 19x plus 10. And that's going to be key when we perform our factoring later today. So what numbers were used to create the leading coefficient? Well, that came from my first, right? My first, 2x times 3x. What numbers were used to create the constant in my polynomial? Well, that came from the last, and so that was the negative 5 times the negative 2. So we need to consider the factors of the first, the 2 and the 3, and the factors of the last, negative 5 and 2, in order to get my ultimate answer when factoring, because I combine both the outside and inside terms to create that middle term, right? So that's going to be our key as we work towards factoring the original polynomial. Let's go ahead and try some together. So we're going to start by making the list of the factors for both A and C. Everybody, A just refers to the coefficient on the first term in my polynomial. So 6x squared, A is just referring to 6. And so what are the integer pair factors for 6? Well, let's make that list. Just like we did yesterday for the lasts, right? We'll do the same thing now for the first because it matters. It'll affect the outer and inner product. So let's go ahead and do that. So 6 has plus and minus integer pair factors of 1 and 6, but also, what else? You can call out. Right, also 2 and 3. Good, thank you. And now I'll focus on the last. My last factor is 5. Well, that only has one pair of integer factors, right? Plus and minus 1 and 5 are the two integers that multiply together to give me 5. Yes? Nothing else. I don't have to worry about anything else. Okay, so now we're going to go ahead and create our parentheses pairs just like we did before. It's just I can't fill in simply x and x for my firsts. Right? I can't fill in x and x for my firsts because x times x doesn't give me 6x squared. my firsts are now going to have candidates. They'll either be 1x and 6x, or 6x and 1x, or 2x and 3x, or 3x and 2x. I've got choices now for my parentheses, right? I can't just go in and fill in x and x anymore, so that's a new layer. My lasts now could be 1 and 5 or 5 and 1. And so I want you to know that it's okay to make a mistake. You have to be willing to try different placements and pairings until we find the winning combination. And your key to checking will be to do a FOIL problem, and we can check and see if we produce the original. So we've got all kinds of choices here. We've got 6x and 1x, right? And we've got 1 and we've got 5, or we've got 5 and we've got 1. I'm going to go ahead and just arbitrarily put in a 5 and a 1 here. And now let's consider, right? Let's consider what outer product and inner product would be created by this placement. And so it's okay if we're wrong, right? It's okay if we're wrong. We want to see what outer product and inner product would be created by this placement right now. So let's go ahead and check. 6x times 1, right, would create an outer product of 6x. Yes? 5 times x is 5x. Do 5x and 6x sum to give me that middle term of 31x? No, they don't. Is this the correct placement? No, it's not. But we've gotten one step closer to the correct placement by identifying this as incorrect, so don't worry. What else can we try? Well, what if we tried the 1 and the 5? And so if we put the 1 in that binomial that has a 6x, and the 5 in the binomial that has the 1x, now let's try my outer product. So look at the red arrow, the big red arrow for outside. What's 6x times 5? 30x. And my inner product now, 1 times x is 1x. Does that sum to give me my middle term squiggling around red? Yes, it does. There's my winning combination. So let's go ahead and finish out with our signs. In order to have a positive last, I have no choice but to have my binomial operations be same sign, and so both negative or both positive. Given that they're same sign, if my middle term is positive, they must both be what? Well, they must both be positive. So let's go ahead and finish it out. It looks like 6x plus 1 and x plus 5. I'm going to go ahead and box this. And I'm going to do a check. So my first would be 6x squared. My outer would be plus 30x. My inner would be plus 1x. My last would be plus 5. And we can see that that does indeed produce my original if I were to combine like terms. So we have to be willing to choose, right, to do a guess and check, to make a mistake, and that's just fine. We might have to rearrange and do several tries in order to find the winning combination, and that's part of factoring trinomials with leading coefficient other than 1. So don't be afraid to make a mistake. Every mistake you make is just one step closer to the correct combination. Let's try some more. So here we got our 6x, our 2x. Sorry, this is just showing all the different possible combinations. Look at that. All different kinds of combinations here. Right? And we could try putting those in until we find the winning combination. Let's try another one. So 8x squared plus 2x minus 15. Not only must we consider the factors of the last, negative 15, we also need to consider the factors of the first, right? That 8x squared. So let's go ahead and list our integer pair factors for that first 8x squared. They include plus and minus 1 times 8, but also 2 times 4. Let's go ahead and consider the integer pair factors for my last, negative 15. Well, plus and minus 1 and 15, but what else multiplies to give me 15? All right, what else multiplies to give me the 15? Brady?
3 and 5.
3 and 5, so that's another integer pair. Anything else? No, we've got them. So look at, we've got 1, 2, 3, 4. We've got lots of different combinations. So we have to be willing to make a mistake. I'm going to go ahead and fill in a couple different parentheses here, because we might have to try more than once until I find the winning pair. So I'm going to make several here, and that's okay. So we know that we could try an 8x and a 1x. We could also try, though, a 3x and a 2x. And we might need more than that. And so I'm going to go ahead and leave more parentheses just in case we have to keep trying.
Wait, so you're in a 2?
I'm sorry, did I say 3x? I meant 4x and 2x is the only way we're going to get to 8x squared. Sorry, that should be 4x the whole time. Thank you, Marco. That was my mistake. 4x and 2x would produce the first product of 8x squared. Everybody good? Sorry about that. Now let's go ahead and try some placements in my lasts and see if any of these are winning combinations. So I could try 1 and 15, or 15 and 1. And if I did 15 with the 8 and 1 with the x, my outer product right now would be 8x times 1 is 8x. My inner product would be 15 times x is 15x. Could I combine 8x and 15x through addition or subtraction and get to 2x as a sum? No. Is this a winning placement? No. And I see that switching the 15 and 1 isn't going to be much help either. Now I created an outer product that's 8 times 15, right, is 120. Is 80 plus 40 is 120x plus 1x. That's not going to get me. That's even farther away. So I know right now that 8x and 8x and x do not go with the 1 and the 15. That's not a winning combination. But we could still try the 3 and 5. Can we try a 3 and a 5? If I tried a 3 and a 5, now my outer product would be 8x times 5. That's 40x. My inner product would be 3 times x. That's 3x. Would 40x and 3x combine in addition or subtraction to get me to 2x? No, so it can't be this placement either. Now you might be thinking, well, we're not doing very well. But each time we get a wrong, right, a wrong placement, that's one step closer to the correct placement. So I'm going to go ahead and flip these. I'm going to flip these and see if we are now going to get a winning combination. 8x times 3 is 24x. 5 times x is 5x. Will 24x and 5x combine to give me 2x in the middle? No, and so guess what? I know we're not going to use the 8x and the 1x placement. So I'm going to now cross that off my list. I know this isn't going to work. But I haven't considered the 4x and 2x placement yet. So let's go ahead and see if we can do a 4x and a 2x placement. Right now my outer product, 4x times 3 is 12x. My inner product is 5 times 2x is 10x. Could I combine 12x and 10x through addition or subtraction and somehow get 2x? Absolutely. And so I have an initial placement, right? An initial placement here that looks like it's good. What we need to do now is consider the interplay between the signs to see if this will in fact work. So what's the sign on my last term? That negative 15 is negative. So the only way to multiply two numbers together and produce a negative last is if their same signs are different. They've got to be different, right? One positive and one negative. Which product will have to be positive and which product will have to be negative so that I sum an outer and inner and get positive 2x? Well, the larger product better be positive so that when I combine it with the negative smaller product, the result is still a positive 2x. And so this is the trickiest part. Here we go. I'm going to make 12x or 10x positive. I want the 12x to be positive. So where should I put the plus? I put it right here by the 3 because now my outer product is positive 12x. And look, a negative with a 5. Now my inner product is negative 5x. I'm sorry, negative 5 times 2 is negative 10x. And that combines to give me the positive 2x. So let's do a quick check. Ready? First, 4x times 2x is 8x squared. Outside, plus 12x. Inside, minus 10x. Last, minus 15. When simplified, will that produce my original? Ding, 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 ding. Winner, winner, chicken dinner. We've got it. So I'm going to go ahead and box this bad boy. We know we found the winning placement. That took us together at least, right, at least 3 tries. And we got lucky on that second placement, right? It could have taken more than that. And so I want you to know it's okay. It's okay to make mistakes. Every mistake you make is just going to be one step closer to the correct placement. And so please go ahead and make several pairs of parentheses on each of these, and we can mess around with the placement to determine the winning combination that produces an outer and inner product that sums to give you that middle term in the original trinomial. All right, so look at all the choices we had this time. So we had lots of different choices for this. We could continue placing these until we find the winning combination, and we did that. Let's go ahead and try some more. Okay, so we're going to do a couple together, then I'm going to have you do a couple with your partner. Let's go ahead and do number 1 together. So stop, think, GCF. Is there a greatest common factor hiding in each of those original terms that would chunk this down into a smaller and smaller polynomial, smaller numbers? No. That 2 is even, the 15 is odd. It looks like we don't have any greatest common factor we can factor out. So we'll go ahead and make our factors of the first and our factors of the last. But I know that we might need lots of choices here. So I'm going to go ahead and make a couple different sets of parentheses. Now I'm going to consider my integer pair factors of the first. 2x squared. Well, that's good news because I only have one pairing, 1 and 2, right? 1 and 2. My factors of the last, though, positive 27, have several combinations. And so I'm thinking of what integer pair factors multiply to give me 27. And I've got plus and minus 1 and 27, but also 3 and 9. Anything else? Oh, 9 and 3 would be the only, we've already got that 3 and 9. Okay, so what's up? Well, we've got some choices now. We can do 2x and x. There's only one pairing for that first, so both of those could be 2x and x. And then we can try our 3 and 9. We could also try 9 and 3. And we might need more because we could also try 1 and 27, and 27 and 1. Let's go ahead and set it, see if one of these is the winning combination. In the first placement, my outer product would be 2x times 9. That's 18x. My inner product would be 3 times x. That's 3x. Upon initial inspection, 18x and 3x, it appears as though we could get to 15x. But there's one problem. Is my constant term in the original polynomial positive or negative? Well, it's positive, and so the only way to multiply two lasts together and produce that positive 27 is if they're same signs. Would 18x plus 3x, same sign, get me to 15x? No, it would get me to 21. So it can't be that first placement. Let's look at the second placement. In my second placement, I have 2x times 3. My outer product is 2x times 3 is 6x. My inner product is 9 times x. That's 9x. Why is 6x and 9x the winning combination? Why is 6x and 9x the winning combination? Eric?
It adds up to 15x.
It adds up to 15x when they're same sign, both positive, right? And so we now need to fill in our plus and our plus. That's exactly right. Thank you, Eric. Let's go ahead and box this bad boy. We found the winning combination. That's sweet. In a factoring trinomial sort of way. Let's jump all the way to 4 and do 4 together, and then you'll be able to do 2 and 3 with your partner. So everybody go to 4. 4 looks trickier because it's got that y squared and the xy term, but it's not. It just means we'll have a y on our last entries, just like we have an x in our first entries. So we'll stop, think, GCF, everybody look at 4. Anything hiding in all of those we can factor out? No, and so we're stuck. We're going to have to make our pairs of parentheses here. Oh, we already have this. Sorry. And we might need more than that. But I'm going to go ahead and start the party. My integer pair factors for my first, right, 10x squared include plus and minus 1 and 10, or 2 and 5. My integer pair factors for the last, negative 3y squared, include plus or minus 1y and 3y. Anything else? No. And so my only difference here is that not only will my firsts have x's attached, my last will also have y's attached. And so let's go ahead and consider some potential placements, like 5x and 2x and 3y and 1y. Let's go ahead and consider this placement. 5x times 1y is 5xy. And 3y times 2x is 6xy. Does 5xy and 6xy sum to 13xy? No, it's summed to 11xy, right? Or 1xy if I did subtraction. So that's not, right? That's not a winning combination. So what else could I try? Well, I could flip these around, right? Couldn't I do 5x and y in one binomial and then 2x and 3y in the other? Now let's consider my outer product. Now my outer product is 5x times 3y is 15xy. My inner product is now y times 2x is 2xy. Could I combine 15xy and 2xy through addition or subtraction to get my middle term? That is 13xy? Yeah, so long as they're opposite signs. Should they be same sign or different? Well, given that my last term is negative, my binomial factors must have opposite operations inside. I must have opposite operations in order to produce that negative last term. So one positive and one negative, which is which? It looks like we need the larger product to be the positive. So I'm going to go ahead and put the plus there, so we get plus 15xy minus 2xy, and we found the winning combination. You see how tricky that is? We've got several layers now to deal with when factoring because of the interplay between that firsts, right? The firsts and the lasts now affect the outer and inner product. So I'm going to go ahead and box this. That was pretty sweet. We found the winner. It took a couple tries. Right now with your partner, I need you to try number 2 and number 3 with your partner. So number 2 and number 3. Make sure you're considering the factors of the first and the factors of the last. Go ahead and make several pairs of parentheses. I'm going to circulate, catch my eye. If you have a question, don't be afraid to make a mistake. Each mistake you make is one step closer to the right answer.
And then you go x squared.
Not this.
Okay, ladies and gentlemen, I've resumed the recording. I know some of you are still looking, or still searching for a winning combination, and that's fine. But I want to make sure we have time for our factoring by grouping strategy, the last factoring strategy we'll look at this semester. And so let's go ahead and get started and list our integer pair factors for number 2. The first, right? The firsts include plus and minus 1 and 2. The lasts include plus or minus 1 and 9, but also 3 and 3. I'm going to go ahead and call on you to share the winning placement in just a minute. And so let's go ahead and see what placement you had for number 2. And so what did you have for your placement for number 2? Logan?
I had 2x and x for the first ones. And I had minus 9 and plus 1.
Minus 9 and plus 1. Let's go ahead and check and see if Logan's placement is the winning combination by doing a FOIL problem. Let's get ready. 2x times x is 2x squared. 2x times positive 1 is plus 2x. Negative 9 times x is minus 9x. And negative 9 times positive 1 for my last product is minus 9. Do my outer product and inner product sum to give me my original middle term? By golly, they do. So Logan has found the winning combination. Nice job. I'm going to go ahead and box this and then ask that you raise your hand if you also found that placement. So did anybody else find this? Several other people did. Hey, that's way better than 2 out of 26. Good job, you guys. Let's take a look at number 3 then. Raise your hand if you think you found the winning combination for number 3. You found the winning combination for number 3? Great, thanks, hands down. I'm going to go ahead and make my integer pair list first, and then I'm going to call on you to share your combination. I just want to make sure that everybody knows our candidates include 1x and 6x, or 2x and 3x. And then my lasts include candidates of 1 and 2 or 2 and 1, right, if I change the order. So let's go ahead and show your winning combination when I call on you. Get ready. So what was your winning combination? KDF?
2x minus 1 times 3x plus 2.
So 2x minus 1 and 3x plus 2. Let's check Katie's placement in a FOIL problem and see how we do. Ready? First, 2x times 3x is 6x squared. Outside, 2x times 2 is plus 4x. Inside, negative 1 times 3x is minus 3x. And last, negative 1 times positive 2 is minus 2. Do Katie's outer product and inner product, the red and green, combine to give me the original middle term? Yes, they do, and so we know that she's found the winning combination. Way to go, you guys. Nice work. Raise your hand if you found number 3. So lots of people found number 2. Did anybody get to number 3? Just a sprinkling, a smattering. Okay, and so I want you to know it's okay to make a mistake in an incorrect placement. Every mistake you make is one step closer to the correct answer, and you have to be willing to make that mistake, right, so that you can zero in on the proper combination. Nice job. What questions are you having about your leading coefficient other than 1, your ax squared type polynomials? Okay. Let's go ahead and check our answers. Yes, 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 yes. We did that. We did that well. The final strategy, right, our last new content of the year is factoring by grouping. And factoring by grouping problems are easy to spot because they're the polynomials that have 4 terms. And we're going to divide those into 2 groups of 2. So it's called factoring by grouping because we're first going to divide these into 2 groups of 2. Let's go ahead and take a look at your note sheet. First, we're going to group the terms together so that each group of 2 terms shares a greatest common factor. If we were to look at those first 2 terms called the blue group, I rewrote the original so that 2ax and negative 6ay were together in a first group. How come? Because they share a greatest common factor. Don't they share a 2a hiding inside? So I rearranged those to have those 2 terms first. They're going to be my first group, and I'm going to call them the blue group. Next, the remaining terms, negative 3by and plus bx, I grouped those 2 terms together because they share a common factor. What common factor do they share? Well, it looks like they each have a b, right? I'll call this the green group. And so after rearranging those and flipping my order for addition or subtraction, I now can, ouch, dirty dog. I'm okay. No, I don't need to pass to the nurse. I'll get on. Now I'm going to factor out the greatest common factor in each of those groups. So everybody take a look at the blue group. Stop, think, GCF. Oh, there's a 2a. There's a 2a hiding inside of that blue group. So we're going to factor that out in a reverse distributive property problem. Go ahead and do that now. 2a times parentheses, what remains? X minus 3y. Plus, now we'll factor out the greatest common factor in that second group, the green group. What's the GCF, the greatest common factor hiding in the green group? B. And so we're going to factor out a b, and then parentheses, a reverse distributive property problem. What remains in the green group? Well, now we still have the negative 3y, and then plus 1x. Now, does a common group exist? Right? After we did those 2 GCF problems, if we've done it correctly, there must be a common group, and that's in black. X minus 3y and x minus 3y is a common group. So my final step is to factor out that group, in parentheses, x minus 3y, out front from each of those terms. Take a look. We'll now factor out that x minus 3y. There's my common group. From each of those, we'll pull out the x minus 3y. We'll do it on this page. I'll put it first. What's common to each of these 2 terms? What do they both have in them?
X minus 3y.
They both have an x minus 3y. So I'm going to factor that out just like we took out a 2a, or just like we took out a b. I'm going to take out a x minus 3y. I'm going to factor that out of that first term. And when I do, what's left? 2a in blue is the only thing that's left in that first term if I factored out an x minus 3y in parentheses. The only thing remaining in that first term is a 2a. What's the only thing remaining in the second term if I factored out the 3 parentheses x minus 3y? The only thing remaining would be the b. And the operation connecting them in this case was addition. So we're actually going to take out the parentheses as our GCF in that last step. Does everybody see that? We're taking out the whole parentheses as our GCF problem for the final step. And then what remains is just the blue 2A and then the green B. I'm not gonna try and confuse you with that next page. I'm just gonna leave it like this. Right? I'm gonna leave it like that. We pull out that, and I'm going to go fast. Aaron, are you timing me? Are you timing me? Ready? What? Oh, let's try another one together. So we're going to factor by grouping. Okay, we're going to factor by grouping. Let's go ahead and arrange these so that they are in two groups of two. We can leave it as is because right now the first group contains the greatest common factor, right? Those first two terms both have x's. But we can also rearrange it and factor out the 2x squared and the 6xy as my first group because they have common factors of 2 and an x as well. So the choice is ours. I'm going to go ahead and leave it as is. We'll leave it as is and see how it goes. So I'm going to go ahead and make this my blue group, and I'm going to leave this, and I'm going to make this my green group. It's okay not to rearrange in this case because I have a greatest common factor present in each. All right, let's go ahead and focus in now on the blue group. Everybody look at the blue group. Stop, think, GCF. What's the greatest common factor hiding inside the blue group? Well, it's just x. And so I'm going to go ahead and factor out an x in that blue group, and that would leave me with 2x plus 5. Is that right? 2x plus 5. Now we're going to go ahead and focus in on the green group. And so cover up the blue group, focus in on the green group. Stop, think, GCF. What's the greatest common factor hiding inside the green group? Well, we've got a couple things. We've got 3 and y. And so we're going to factor out a 3y from the green group in the GCF problem and see what remains. All right, 3y times what equals 6xy? 3y times 2x equals 6xy. So 2x remains. Plus 3y times what equals 15y? 5. If I'm doing factoring by grouping correctly, the first level of GCF problems should result in a common group. Do we have a common group? Yeah, the common group present in each of these terms is the parentheses. That black factor, 2x plus 5, is common to each of these groups, right? It's common to each of these groups. So my final step is to factor out the parentheses, that 2x plus 5, from each term. If I were to factor out that 2x plus 5 from the first term in a reverse distributive property problem, what remains? Well, the only thing that remains in that first term is that blue x. Does everybody see that? That's what remains in that first term. It's the blue x. If I were to factor out a 2x plus 5 in parentheses from the second term, what's the only thing that remains? A plus 3y. So my final answer is 2x plus 5 times x plus 3y. And you might see this in the answer keys in either order, right? You could see that in either order, x plus 3y first, and then 2x plus 5. That's pretty sweet. So I don't want the next part to confuse you, but it might help you. So we divide those into two groups. We did our blue group, GCF. We did our green group, GCF. Notice that common group in red, 2x plus 5. That got factored out in the last step. In our order, we did differently because we're used to factoring it out in front, and so that's just fine. All right, we're going to go ahead and try again. Stop, think, GCF. Is there a greatest common factor present in the first two? Is there a greatest common factor present in the second two? If there is, we don't have to reorder. And so if there is, we don't have to reorder. We could leave this as blue group and green group. All right, now we'll do a GCF with just the blue group. Stop, think, GCF. What's common to each of those in the blue group? Well, we've got a 2 and we've got an x. So we'll go ahead and factor out a 2x if we factor out a 2x, that will leave me with x minus 3y. Is that correct? Did I do that correctly? Awesome. Now we'll go ahead and cover up the blue group and focus in on the green group. The green group. Is there a greatest common factor hiding in the green terms? Yes, there is. Right? It looks like 5. Is that it? Just 5? So I'll factor out a 5. When I factor out a 5, what remains? Well, 5 times a negative 3. 5 times a negative 3 equals negative 15y. And then plus 5 times, what, x equals that second term, 5x. I know I'm doing this correctly if I have created, right, a common group. Have I created a common group? Well, if I took the time to reorder this, I would have positive x minus 3y, which matches positive x minus 3y. So I'll go ahead and do one more, right? I'll go ahead and do one more step. Group it. Clone it. Reorder it. That's so mean, Mr. Fritz. You did just clone that. And now we have to rewrite the whole thing. Do I have a common group? Yes, look at that. X minus 3y and x minus 2y, squiggle underline red, is common to each of those. So my final step will be to factor that out. As the GCF in each of those two big terms. And after factoring out the parentheses quantity, x minus 3y, what remains in the first group? Just 2x. What remains in the second group? Just plus 5. So x minus 3y times quantity, 2x plus 5. And again, you might be thinking, no way. Right? That doesn't look at all like our previous factorizations. But guess what? We could still do a FOIL problem to check. X times 2x is 2x squared. X times plus 5 is plus 5x. Negative 3y times positive 2x is minus 6xy. And negative 3y times positive 5 is minus 15y. If I were to reorder those terms, in addition or subtraction, would I have equivalent to the original? Boy, howdy. So we're winning, which is what we strive for, day in and day out. All right, so this shows how we could reorder that, right, and pull out the common group. All right, guys, so we're now equipped with most of the factoring strategies. Frequently, more than one layer of factoring is required to produce the complete factorization of a polynomial. If a polynomial cannot be factored, we say that it's prime. And so if we can't factor a polynomial, right, we say that it's prime. Just like prime numbers, right? It can't be factored into any other integer pairs besides 1 and the number itself. So we're going to follow those rules in order and always do the GCF first. Let's try a few together. So stop, think, GCF should always be your first step. And so our first step then is always to factor out a greatest common factor, if possible, because that'll chunk it down into smaller numbers. As I scan this problem, I notice that every term does include a 2 and an x. And so I'm going to factor out a 2x to create a smaller problem and then easier subsequent factorization if necessary. So we'll factor out a 2x. That will leave me with x squared plus 5x plus 6. Everybody see that blue polynomial remaining? But that's not all. I'm not going to stop here. I'm going to see if I can factor that blue trinomial into a product of two binomials, my favorite kind. So I'm going to go ahead and keep that 2x. If it was hiding in my original terms, it's still going to be part of my answer. But I'm going to keep going with, I'm going to go ahead and just scooch this a little bit more. I'm going to keep going with that blue trinomial, and see if we can't continue factoring. So I'll keep my first x and x, and I'll consider the factors of the last. My integer pair factors of the last include 1 and 6, but also 2 and 3. Given that my last term is a positive 6, which pairing will I use? The 1 and the 6 or the 2 and the 3 so that I get my middle term of plus 5x? So what pairing is this going to have to be? Carson?
2 and 3.
The 2 and the 3. Good job. They must be same sign, both positive. Therefore, we can't use 1 and 6 because that would sum to give us a positive 7x. And our middle term was positive 5x. So we have to use the 2 and the 3. Nice job. Same signs, both positive. Way to go. That's perfect. Good job. Stop. Think. GCF. Is there a greatest common factor hiding in each of the original terms that can be factored out? You bet your boots. And doing so is going to result in an easier factorization problem. So I'll go ahead and pull out an n to the third, and that leaves me with n squared minus 100. Some of you might be tempted to box this answer and go on to the next one. But look, what kind of number is 100? What kind of number is 100? Braden?
It's a perfect square.
Yeah, it's a perfect square, and so that's an indication that this might be a special pattern, right? It's also 2 terms in that binomial that's green. 2 terms, and so this could be a special pattern. Let's keep going. If n cubed was hiding in the original, n cubed is going to be part of my answer. But let's try and factor that green trinomial further. What times itself equals n squared, n, and n. What times itself equals 100? 10 and 10. If my last term is negative, then I have no choice but for my signs to be same or different. Different. So one must be positive, and one must be negative. That's great news because my outer product now, negative 10x, and inner product, positive 10x, would sum to give me 0 ends, so I wouldn't have a middle term, which is why we had we had a green binomial in the first place. So we're doing well. Awesome. Couple more. What technique could be used when we have a 4-term polynomial? So what technique could we use when we have a 4-term polynomial? Taylor? Grouping. Let's go ahead and see if we can't factor this by grouping. So let's look at the first 2 and see if they share a greatest common factor. If they don't, we'll rearrange and try again. Do my first 2 terms share a greatest common factor? They do, so we'll make that our green group. Do our second 2 terms share a greatest common factor? They do, we'll make that our green group. Now we'll focus in on that blue group. Stop, think, GCF. What's common to each of those terms? Well, they both have a 3a, and so we're going to go ahead and factor out a 3a from that first group. That would leave us with b plus x. Now we'll look at that second group. Is there anything common in the second group? Yeah, they both have a negative 2. Don't they both have a negative 2? So in the green group, I'm going to factor out a negative 2 and see what remains. If I factor out a negative 2, then I would have a positive b remaining and a plus x remaining, because negative 2 times b is negative 2b, and negative 2 times positive x is minus 2x, and so my signs match here. Have I created a common group? You bet your boots. That black b plus x is common to each of my big terms. So I'm going to factor that out. B plus x in parentheses. And all that remains then is my 3a from the blue group and the minus 2 from the green group. So my final answer then is b plus x in parentheses times 3a minus 2 in parentheses. And we could always check that with the FOIL. Stop. Think. GCF. Is our greatest common factor hiding in number 4? No, but I wish there were. Those are pretty big numbers, aren't they? I mean, they're pretty big numbers. but we're going to be stuck anyhow. We're going to have to list my factors of the first. Plus and minus 1 and 4, 2 and 2. List my factors of the last, underlined blue. Plus and minus, yikes. 1 and 24, 2 and 12, 3 and 8, oh my gosh, go guys, darn. 4 and 6, 5 and, no, and then back to 6 and 4. So look at, we've got all these choices, right? So am I going to sit here and make 8 pairs of parentheses? Well, we need a bit more than that, right? Because then we could reverse those order to 16 pairs of parentheses. No, I'm going to make several pairs, and then I'm going to try, right, using my knowledge of the FOIL pattern to create an inner and outer product that sums, give me that middle term, negative 35b. But I've got some tools at my disposal. For example, my last term in blue is positive. Therefore, my entries are going to be same sign or different. They're going to be same. And given that they're same, are they going to be both positive or both negative? If my middle one's negative, yeah. And so in this case, I really know that this is minus and minus in each one. So that might help. Let's go ahead and try a couple placements. 4B, B, 2B, 2B, and, I'm going to try 6 and 4, and I'm going to try 8 and 3. All right, my current placement in the top parentheses results in an outer product that is minus 16b and an inner that is minus 6b. Does that sum to give me 35? Nope. Let's switch it. My outer product now is negative 24b minus 4b. Does that give me the 35? No. My second parentheses, 2b and 3 is 6b. 8 times 2b is 16. 6 and 16 is, again, 22. Nope. So I'm going to switch. Whoa. 2b times 8 is 16, and 6 is still 22. So I have not created the correct placement, even though I've tried 4 times. What should I do? Quit? Ask for a pass to the nurse? Have my mom call me in? No, I'm going to stay strong, and I'm going to try something I haven't. We haven't tried, check it. We haven't tried the 8, or half of the 8. We haven't tried the 8 opposite the 4. Guys, take a look. What if we do 4b times 8 is 32b, and 3 times b is 3b? Can we get to 35? Woohoo! So we found the winning placement because of persistence, right? We persevered and we found the winning placement using our knowledge of outside versus inside product. Awesome. All right, 2 to go. Stop. Think. DCF. 2b squared what does that leave us with? Leaves us with b squared plus 5b minus 36. All right, 36. Oh, it doesn't stop there. I bet that trinomial in blue will factor into a product of 2 binomials, where my firsts are b and b. And this isn't too bad because I only have to consider the factors of my last. Since it's a 1b squared, I can already fill in my b and my b. And I only need to consider my plus and minus factors of 36. So 1 and 36, 2 and 18, 3 and 12. Oh my gosh, I thought this was going to be easy. 4 and 9, 6 and 6. So what about the nurse again? Nope. We all can see the winning pair because you guys are getting good. We know that these are going to be same signs or different. They're going to be different. Because my last is negative 36, I know that these are going to be opposite signs. One positive, one negative. Therefore, even though I've got 5 integer pairs that multiply to 36, only one of these is correct because I have to sum to get a positive 5 with opposite signs. So which one of these is going to be correct? All right, which one of these is going to be correct? Jackson? The 4 and the 9, absolutely. Good job. We have to use the 4 and the 9 in order to get to that positive 5, which is which? Well, it looks like we need the larger one to be the positive, so we better put the plus 9, and the smaller one to be negative, so we better put the minus 4 so that they sum to give me the positive 5. Good job. Way to go. That's right. You guys are pretty awesome. You guys are pretty awesome, this could say. And then lastly, we've got t to the 4th here in 3 terms, but this is really just what we call a quadratic form. It's still going to be a binomial. It's still going to be a binomial. It's just that my first won't be t and t, they'll be t squared and t squared in order to multiply together and give me t to the 4th. Then my outer and inner product will still sum to give me a t squared term. Let's go ahead and consider my factors of the first. Plus and minus 1 and 3, that'll make things easy. Plus and minus 1 and 2, that'll make things easy. And we'll try 3t and t. And we'll try 1 and 2. Right now, my outer product will be 3t times 2. What's that? Well, that's 6t, and my inner product is 1t. Hey, 6t and 1t, I'm sorry, squared. We need t squared the whole time, guys. Guys, we gotta add t squared. Sorry about that. The only way to get that t to the 4th is t squared times t squared is t to the 4th. Right now, my outside is 6t squared. My inside is 1t squared. Initially, we think, oh, we can get to 5t squared, except for one problem. Are these going to be same signs or different in my binomials? They have to be same signs, so they must both be negative, which means that this placement, although initially promising, is wrong. This would give me minus 6t squared minus 1t squared is minus 7t squared, and that's not right. We need minus 5t squared, so what do I need to do? Let's try flipping it. Let's try an outer product of 3t minus 3t squared and an inner product of minus 2t squared. Now we get the minus 5t squared, so we had to rearrange that to make it work. Nice job. And I think there's one of those, right? One of those on your worksheet. Number 4. All right, so in general, we've got our stop, think, GCF we always want to do first, and we included this in your handout next class. We want to stop, think, GCF is going to be our first strategy. If after factoring out a GCF, or there isn't one, we consider, is it 2 terms? If so, it could be a special pattern, where a difference of perfect squares results in a plus b times a minus b. If there's 3 terms remaining, we could still consider a special pattern if there are perfect squares. So if there are perfect squares, it might end up being an a plus b quantity squared, or if there is a squared minus 2ab plus b squared, then that could have come from a minus b quantity squared. Or if it's not perfect square numbers, then we could do my favorite kind, that's undoing FOIL. So we could factor that trinomial into a product of 2 binomials. Don't worry, you'll get this next time. I just inserted it. I made this and inserted it this morning. You guys don't have it in the note sheet though, because it was at Copy Center. And lastly, if there are 4 terms, that was our final strategy. What could be a candidate for factoring by grouping if there's 4 terms? And we'll get this next class. All right, so let's go ahead and close it up for the day. Go ahead and select the correct response. When factoring a polynomial, what's always the first method to try? When given a polynomial with 2 terms, what's the special pattern that may exist? It could be a sum of squares, or a square of a sum, or a difference of squares, or a square of a difference. And lastly, what strategy should be tried when attempting to factor a 4-term polynomial? Go ahead and complete these and be ready to share with the class when I call on you. Okay, ladies and gentlemen, when we're factoring a polynomial, what's our first method that we should always try? Go ahead and share with the class the response for number 1. Will?
The GC.
Yeah, we want to see if there's a greatest common factor hiding inside. So raise your hand if you had B for the first one. Greatest common factor is what we should always look for first. Great. When given a polynomial with 2 terms, right, which is the special pattern that may exist, right? Which one is that going to be? Dakota? What's that?
C.
C, absolutely. A difference of perfect squares is the only 2-term polynomial that we could continue factoring, right? And lastly, what strategy should we try when attempting to factor a 4-term polynomial? What worked for that? Margot?
B.
What's that?
B, factored by grouping.
B, factoring by grouping is absolutely correct. Right here, if you have B for the last one. Factor by grouping is a 4-term. Way to go, you guys. Nice work. I want you to know that your assignment, again, does not include any reading questions, and it's just the worksheet number 4, quiz in 2 class periods. So next class, day 5, we'll get a little quiz review worksheet, and then you'll have your final quiz of the semester that will go on semester coursework grade in 2 class periods. After that, we'll review for the final exam. I'm going to go ahead and stop the recording and save it. Great job today, you guys.